Alright, hello everybody. Today we're doing lesson 7.2. It's our intro to scientific notation. So we are starting with powers of 10. And so today we want to evaluate and multiply by powers of 10, and we want to convert them from standard notation into scientific notation. Alright, so a little warm up. You just grab your calculators. 123 times 1,000. That's going to be 123,000. Right. Now if I do 123 divided by 1,000, that turns into 123 thousandths. So if you remember your decimal places, the thousandths are the third, so 0.123. Right, number 3, I can take 0.003, multiply it by 100, and I end up with 0.3. If I take that same 0.003 and divide it by 100, I get 0.00003. Alright, so you might be noticing some patterns, maybe not, but hopefully after this next section we will. Alright, so the table below shows the relationship between several powers of 10. Alright, so first we have 10 to the third power. So remember, that's 10 times 10 times 10. So that's 1,000. 10 squared, 10 times 10 is 100. 10 to the first is 10. 10 to the 0th is 1. And now 10 to the negative first, we could say 1 over 10 or 0.1. Alright, and since we're in scientific notation this lesson, we're going to use decimals, even though last time we used fractions. 10 to the negative second is going to be 0.01, and 10 to the negative third, 0.001. Right, so a couple things you might notice is each time we divide by 10, the exponent drops by 1. And the decimal place moves 1 to the left. Alright, so as your exponent's going down, your decimal is moving to the left. But the other way, each time you multiply by 10, the exponent goes up by 1. Right, that's because we are in base 10. We're just multiplying everything by 10. Kind of like on Thursday's lesson, we talked about the power of 2 and how we were dividing by 2 since that was our base each time. So this time, the decimal moves 1 to the right if our exponent is going up. Right? Each place is a tens position. We're in a base 10 number system. Right, so we get to 10 and then we start over. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20s, 30s, 40s, 50s. Right, then you go to 100s, 110s, 120s, thousands. All right, so everything is a base 10. So that's why we use 10 to some power. All right, so I'll see you on the next page. Actually, really quick, right down here, this little chart at the bottom. This just shows if you have 10 to the fourth, you should have a 1 with 4 places after it. Right? If you have like 10 to the negative 6, there should be 6 digits after the decimal. All right, so warming up, 10 to the negative 6th. Well, I know I'm going to start with a 1, and that's where my decimal would be. And then since I'm to the negative 6, I'm going to move it back left 6 spaces. 1, 2, 3, 4, 5, 6. So this is where my decimal is now, but I need to fill in all these little spaces with zeros. So 0.00001. All right, number 2, we have a positive exponent, 10 to the fourth. So that's going to be a 1. And here's my decimal. I'm going to move it 4 times. 1, 2, 3, 4. So my final answer is 1 with 4 zeros, or 10,000. All right, 10 to the 9th. I know with my shortcut that's going to be a 1 with 9 zeros after it. So it's looking like 1 billion. All right, number 4, we're switching back to negative exponents. So if I start with the 1, and there's my decimal, I need to move that back twice. So I end up at 0.01. And if you don't believe me, remember 10 to the negative second is the same as 1 over 10 to the positive second, which is 1 over 100, which is 1/100th. All right, if we move on to number 5, 10 to the 5th. 10 times 10 times 10 times 10 times 10. So 5 times. Our shortcut, we have a 1 followed by 5 zeros. 100,000. And our last one is 10 to the 10th. It's going to be a 1 followed by 10 zeros. All right, the reason we can start all these off with a 1 is because we are in base 10. So everything is 10 times 10 times 10 a certain amount of times. So everything will end in a 0 and start with a 1. All right, now we are writing each write each number as a power of 10. So above we are moving our decimal a certain number of spaces. So now I'm going to do the opposite. I'm going to figure out how many spaces do I need to move my decimal until I have just 1. All right, so my decimal for a million starts there, and I would need to move it 1, 2, 3, 4, 5, 6. Right, if I put the decimal there, I end up at 1. So we would say this is 10 times, 10 to the 6th power. On number 2, we're moving it to the right, so we're going to have a negative exponent. So I would move this one 1, 2, 3, 4 spaces until it would turn into a 1.0. So this would be 10 to the negative 4th. All right, number 3, starting at 1,000, I would need to move the decimal 3 times to the left. So that would be 10 to the 3rd. 10 times 10 times 10. Right, number 4, 100 million, the decimal's at the end. So in order to turn that 100 million into a 1, I need to move the decimal 1, 2, 3, 4, 5, 6, 7, 8 spaces, or 8 tens places. So you would have 10 to the 8th. All right, number 5, 0.00001. So again, we're less than 1, so we're going to have a negative exponent. So I need to move this decimal 1, 2, 3, 4, 5 spaces over. So we would have 10 to the negative 5th. And lastly, 0.1, we would only need to move that 1 space, so that would just be 10 to the negative 1st. All right, so if you're starting with a big number, you'll have a positive exponent. If you have a very small number, you'll have a negative exponent. All right, you always want to turn it so the decimal is right next to the 1. That's it for today. Let's go take care of that LT check.